Hi, I'm Aaron Green, and I'm the project manager.
Hi, I'm Connor Smurl, and I'm the manufacturing engineer.
Hi, I'm Chris Bruzy, and I'm the design engineer.
Hi, I'm Jack Dyer, and I'm the marketing coordinator.
Hi, I'm Jack Shaw, and I'm the graphic designer.
And
we are the Belmont Hill Drone Club.
The new Belmont Hill Drone team is formed from the recently made Belmont Hill Drone Club. The team colors are consistent throughout the project, being red and blue, and are visible in the drone and the team display. Despite the whole team having separate roles, everyone worked together on the design and testing process to make a working and highly functional drone.
Our goal was to build an agile, light, fast, and durable drone that was able to comfortably lift the payload and easy to take the payload in and out. We also wanted to make sure that it was fully made out of 3D printed parts so that we can easily replace parts that were broken. We wanted to make sure that the electronics would easily fit in the drone and that there were no stray wires affecting any propellers. As Belmont Hill Drone Club, we wanted to include our team's identity into the drone, and we did that using colors. So our drone is colored black, red, and blue.
For the prototype, we started with a bunch of different versions. We allowed everyone on our team a chance to build a prototype, and we used CAD and Fusion 360 so that we could share components and parts of the drone that were working and just work on the parts that weren't. For example, we had one prototype with only 3 spokes, and as soon as we printed it, it just kind of broke. They were too thin, and it just didn't work. So we used the stock frame for ideas then to figure out what type of thickness we needed, how many spokes we needed, and just how our drone would fit together. Once we had a design we were happy with, we started thinking about the materials we would use as well as how the different components would fit together. So then we started to print these separate components with different materials just to see how they would fit and if there was any other adjustments we needed to make, which at that point it was just finalizing.
To test our drone, we used a variety of different methods, some to just test the durability of the actual drone, some to test the capabilities such as flying and aerodynamics. Firstly, we did a spike test, which was literally just throwing the different components, for example, the frame or the camera holder at the ground just to make sure they were durable enough to withstand a crash if we were to crash the drone, so that we wouldn't have to print a ton of extra parts just to replace it every single match. Additionally, we practiced racing the drone. We would fly it through the PLA race course, and we would see when it fell out of the sky if any of the components broke when it hit the ground, just to test different materials. Additionally, we tested a variety of different size batteries just to try to find a balance between actual weight of the battery and how much it was weighing the drone down versus the flying capabilities and how much time the battery would last for. Finally, we tried 2 different configurations for the drone. We tried a pusher configuration with the propellers facing downwards, and we also tried one with the propellers facing upwards, and we actually found that the propellers facing downwards was a better configuration because it actually wasn't blocked, which Bruzy will explain more later.
So during our prototype, test, and refine stage, we frequently revisited the materials we were printing and using. So for example, the camera canopy and the payload mount both needed to be fairly flexible, so we kind of had to use a TPU material for that. But other parts, such as the prop guard piece and the main plate, needed the highest impact resistance possible while still remaining stiff. So that was our hardest challenge. We tried PETG, polycarbonate, carbon fiber infused nylon, and also a tough version of PLA. TPU was way too soft for these pieces. Polycarbonate, we had problems with bed adhesion and printing. CF nylon was very brittle, surprisingly, and PETG simply wasn't strong enough, so we finally settled on a tough PLA because it's incredibly stiff, but it's very resistant to cracking and shattering.
During our refine stage, we looked at the current model of our drone in our CAD, and we looked at how we could find and design the most durable and well-fit parts so that the drone would obviously be able to fly at the peak of its capacity. We used the information that we gained from all the failed testing to put it forward into a newer and better design. So one thing that was really helpful for us was using 3D printed parts because they're very cheap to manufacture, very easy to make, and then obviously very replaceable. So whenever we had a broken part, it was not too hard to print a new piece and plug it back in. Then the other upside of 3D printing is that you can choose the different infills and the different materials to print with. So of course there's a balance between stiffer pieces that are also end up being heavier versus lighter and more flexible pieces. So we used a wide variety of tests to find the sweet spot, find the best ratio of weight to strength.
So for our final design, we decided to go with a variety of materials. TPU, a flexible material for our payload mount and our canopy, just for that flexibility and durability. PETG was for our outer prop guard, for a little more durability than PLA while remaining stiff and just resistant. And then just plain old PLA for our main plate for a stiff kind of base for all of our electronics and motors. In addition, we went to build the drone with a pusher configuration, which meant we basically just flipped the motors and propellers upside down, so there's virtually nothing directly under the propellers anymore to reduce the drag right under our propellers and basically increase our performance and efficiency. We used long center screws for the standoffs going through the middle of the whole drone just to reduce weight and increase rigidity. And to finish it all off, we printed all the parts in our Belmont Hill colors, so blue and red and some black for a sleek look.
Thanks to our brand new makerspace and our brand new budget for robotics at Belmont Hill, we were able to have a myriad of resources and great support all along the way in order to build the very best drone and support the very best robotics teams that we could. And then, once we had a beautiful drone going and a perfect drone club, we began to market our club on various social medias, including Instagram, TikTok, Twitter, all across the board. We also sent lots of all-school emails to try to garner as much support as we possibly could. And then if you'd like to check out our Instagram or our TikTok or our Twitter, they're all at BH Drone Club. So give them a follow. Drone Club to the moon, baby.